Long-term viewers of the channel might recognize this guy. This is the Balena Etcher Pro, and you plug in power and it boots up into a little flasher system that you can put multiple microSD cards in and flash them all at the same time. I used this on the MrBeast video project where we needed to flash 100 operating systems in a very short amount of time, and Balena sent this over to help with that project. And I've only used it like 3 or 4 times since then. But then the question comes up, how do you flash these guys quickly? These are Raspberry Pi Compute Module 5s, and I've made multiple clusters of these, usually between 4 and 8 nodes. So it's not the end of the world to use like a Compute Module 4 or Compute Module 5 I/O board and plug it in via USB. And this is the one that I normally use for that. I would plug this board in via USB-C to my computer and flash through here. You have to put a little jumper on these pins. That works, but this is a little bit annoying. It takes up a lot of desk space. This is the other one that I use. This is a Nebra flash stick, and it works with the Compute Module 4 and barely works with the Compute Module 5. The big problem is the power input through here isn't enough, and sometimes it'll be flashing and then it'll just drop off. The other problem that you have with these solutions is you can plug these things in over and over using these board-to-board connectors. These are called high-rose connectors. But if you look up the spec sheets for these things, they're only rated for like 20 or 40 insertions before they are not going to meet their rated specification for like insertion loss and all that. That basically means the signal quality from these degrades over time as you use them, as you plug things in and out repeatedly. These were never designed for the use case of like popping in lots and lots of Pis when you're flashing a lot of them. While I was editing this, I actually remembered that when I was at the Pi factory in 2023, I got to see kind of their prototype CM4 automation line where they were smashing the CM4s into the high-rose connectors that you see here. And I'm guessing that they had reliability issues with those because they're not rated for that many, thousands a day per machine. It's not rated for that. But the problem that people have had is, how do you flash, like if you're making a production run of 1,000 things with Compute Module 5s in them, how do you flash an operating system to them? How do you secure them using Secure Boot? How do you put your signed keys on here and all that stuff? How do you do that like 100 or 1,000 or 10,000 times? Boards like this are not the way because it's a lot of work, and you'd have to have multiple of these. You'd have to have somebody at a computer clicking a bunch of buttons. Not very fun. And that's why things like this exist, but these are an incomplete solution too. The Compute Module 5 actually has a bunch of test points on the bottom. See all these little shiny blobs? And what you can do with that is make a bed of nails. And I'm going to show you what that looks like in a minute. Whoa, well, hopefully that one still works. When I went to the Raspberry Pi factory, they had things like this. This is the CM5 Programming Jig. This is a fixture for basically production scale Compute Module 5 flashing. And this is for if you are at a factory scale flashing Compute Module 5s. I'm guessing that there's a Compute Module 5 or a Compute Module 4 inside of here running this thing because it runs Linux. But here's what this does. You push on this and this comes up and you'll see some little dots in there. I'm not going to touch them because you don't want to get any finger oil on them. But you can see when I push down, see those pins? So those pins touch on all the little points on the bottom of this Compute Module 5, those little silver balls, and you index it on the screw holes like this, and then you push this down, and as you push it down, it will secure the CM5 against those little pin pricks, those little bed of nails, and it also presses on this button to let this device know, hey, there's a Compute Module 5 in here, start programming it. So what you can do is you plug this into your network and you can set it up so that you can program multiple Compute Module 5s very quickly. Let's say you had 3 or 4 of these. You could do 4 at a time, and it will flash an OS to it. It'll read the information off of the Compute Module 5, like serial number, MAC address, all that kind of stuff. Dump that into a database, and then you can take them out and keep them going on your production line. There is another project similar to this. It's called the CM5 Flash Jig from EveryPin, but that one costs around 2,500 bucks or like 2,000 euros. It's very much like this, but it uses the EveryPin's open source software and ties into their electronics testing ecosystem, made for testing mostly, but you could probably do things like flash the CM5s through it too. They also have this really cool mapping to show you where all the test points go here. But this is a first-party solution. I think it was made in collaboration with EDA Tech or EDA Tech, And it's meant for people who are putting these onto production lines and getting tons of CM5s flashed and getting that kind of in a pipeline. It comes with a few accessories, like it comes with a power cord, because I think it uses 12-volt power, and some power adapters. And I think there's also a network cable in here because you can plug, it comes with some spare nails. These are pogo pins that are very tall and prick into the bottom of the board. But it also comes with a Wi-Fi antenna because the unit can run on Wi-Fi or on Ethernet. And then there's also a device under test Ethernet. So this port plugs straight into the CM5's Ethernet port so that you can copy data over to it more quickly, because copying data to the eMMC on here through USB 2 speeds is not all that fast. But yeah, it comes with a couple cables for that. And it's really meant for companies that are building Compute Module 5 based products. It's not really meant for you and me. I mean, there are some people watching this channel who I think this would be a great product for, but the number of people is going to be in the very small percentages, especially with the prices of Compute Module 5s being what they are right now. But there are, I mean, here's the thing. A lot of people say like, oh, Raspberry Pi abandoned their mission and all that. One thing that I have found is a lot of people who wanted to build a product that they just needed Linux on it to run something. This is still the most cost-effective way, not just the cost of the unit itself, the Compute Module 5, but the cost of the ecosystem in terms of programming it, putting together a product that will work over 5, 10, 20 years. All those things are part of it. The total system cost is much lower with the Raspberry Pi than a lot of other solutions, or especially than integrating your own board together with a system on module. That's what this does. I'm going to try to get this to work. I have not plugged this in yet, but you have to flash an OS to the jig, and then you put your image on the jig, and then you can flash it to a CM5. But I'm going to see if this thing works with the laptop that I've been testing. This is a laptop from Dell that I've been using over here at the workbench. It's kind of ridiculously overpowered for my particular needs, but it does have one of the faster Intel mobile chips right now. Let me get this going. I'm going to download Raspberry Pi Imager. We'll plug this device into my network, which is over here. So we'll get the Jig Ethernet going. I'm going to plug the power supply in to give this system power. I'm going to close this for now since we don't need to be doing any flashing yet. Looks like the power supply they provide, it's from K-Tech, and the output is 12 volts, 2 amps, so 24 watts. Okay, so I have it plugged in. We got a red light. I think that just means it's booting up. And no, I do not want you to back things up. I hate Windows so much. Every time you boot the thing up, it does something that's annoying. I don't know if that's like a directive from Microsoft's product team or something, like make the user annoyed every time they use this thing. But I'm going to download Raspberry Pi Imager on here, and then we'll plug in USB to flash this thing. That's one interesting thing. It doesn't come with a USB cable. It only comes with Ethernet. So I'll have to go dig out a USB cable to plug into here. One thing I like about this laptop is it has full-size HDMI, USB-A, 2 USB-C over here. I think they're USB 4/Thunderbolt, and then USB-C over here, a lock slot, and headphone jack. A good assortment of ports, although it doesn't have a card reader. So I got USB plugged in, and let's download Pi Imager. So I'm running 2.0.10, but apparently this needs 2.0.11 or later. I'm going to go try to find that really quick, and I'm going to download that, get it set up, and then we'll come back to this in just a second. Hold on. Okay, I'm working off a draft version of the documentation for this thing, and I found that you can get the latest version of Pi Imager off the GitHub, so I did that, and I'm going to follow their directions to select the programming jig. And then I think I can choose the Jig OS, which is, I guess, slightly customized for this thing. And I don't see the storage device. Why am I not seeing that? Control-Alt-S, enable RPi boot. Okay, so I guess I need to unpower this and power it back up. Oh, there it is. Okay. Oh, 120 gigs. So they give you a little bit of a generous proportion of storage on here. Washington, D.C. is my capital city. Time zone is Chicago. Username. Okay, and I'm going to connect this to Raspberry Pi Connect so I can remote control this more easily using the GUI. Okay, so it is now flashing the Jig OS onto here, which is Pi OS with some extra customizations for the Jig. And hopefully that will finish up pretty quickly here. While it's doing this, I'm going to go back over here. It said to make an image. The Secure Boot Provisioner, RPi SB Provisioner, is available through here. You connect to it and then run it on there. There's ways that you can get that to be directly accessible over the network, but it's more secure if you do everything on the device and then set it up to be completely automatic. But I'm going to do that in just a minute. I'm going to make an image for the Pi. I'm not going to make like a full-fledged image with security features and all that kind of stuff, but I'm going to use PyGen to build an image, and then I'm going to transfer that image over to here. I'm using Raspberry Pi's PyGen tool to use Docker on my Mac to create an image with this information to create a PyTrixie image. Okay, so on my Mac, I built the image using Docker. You can actually do it on Windows too, but I didn't have Docker set up on here. I didn't want to go through all that stuff. So I set it up using PyGen, and I set up a magic wormhole, and I made sure this is connected to Raspberry Pi Connect. So I should just be able to go into screen sharing on here. This is the UI for it, and that's an interesting UI. I don't know exactly what all that stuff is, but that's okay. I'm going to receive the file. So on here, I'll just receive it right into here. So I'll say wormhole. It looks like it was already installed on here. Wormhole receive. So that should receive this file from my Mac directly onto the CM5 Programming Jig. And once that's done, I should be able to start flashing that to CM5s. The nice thing about doing it this way is I got that at 110 megabytes per second, which is basically line speed for the Ethernet port on here. So you definitely want to do things over Ethernet and not do it through the USB 2.0 port. So we did magic wormhole, we sent it, and we'll go to, is it options? OS image. And we'll browse right here. I guess it's putting it into a different folder on the file system. It'd be nice just to upload it straight into the place where it wants. Storage type is eMMC. Firmware, we'll choose the latest. We're going to do a naked OS image, but this is where you can set up your keys and all that kind of stuff. If you want to set this up for a, if you're doing like a business deployed thing with a secure boot chain and all that stuff, you want to do all that. There's a database where it will store all the information about the device, so the serial number, MAC address, hardware details, customization database. So this will show the database of CM5s I've flashed, I guess. And now the question is, how do I actually start flashing? Let's see here. Program and compute module 5. Okay. Make sure it's powered on. The status is green. That's good. Connected to a network. Okay. Configured. Insert the CM5. I don't know what this will do while we're doing the flashing. So this should all be set up at this point, and I should just be able to put this in here. If I pop this up, set that down, close it, and push down. Okay, it's blue, and this did change. It looks like it's saying that Bootstrap started, and it should take 1 or 2 minutes. And over here in the interface, it's showing me the status. So this is not something that you need to actually follow along with at all. This is something that this would just be on a automation line, and it would be doing this, and you'd put CM5s into it. But this is logging all the things that it's doing. So it finished the Bootstrap. It's doing stage 2. Now it's provisioning, so I guess it's copying the image file. And I'm seeing a red blinking LED over here. I hope that doesn't mean something failed. Okay, so here's the whole log. Customization script, naked provisioner at stage provision failed. I probably did something wrong in the PyGen. I'm not sure about that. I didn't do it all the way that Raspberry Pi said, like, do it this way. So, you know, it's probably a me thing and not a Raspberry Pi thing, but it looks like it's not, because it did fail, it looks like it's not updating this manufacturing database either. But since it's been, let's see, it's been about 3 or 4 minutes now, so I think that we failed on this one. I'm going to pop it out. Okay. And, whoa, yeah, this is the one that I keep dropping. I should probably stop dropping it. And I'll put in this one, and we'll see if we have any more luck. It says provision failed here again. So I think my image might have an issue. That's my guess. But anyway, that's how this is supposed to work, and I'm not going to debug this today because this is the day before this comes out. I was on a trip. I'm preparing for another trip the end of this week, so I don't have time to finish debugging this and get it to work correctly with an image. But you can imagine once you do get the bugs sorted out and you get a green light at the end of this, being able to do this and pull out a Pi, put in a new one, clamp it down, and it's flashing automatically. And it's logging all of these Pis into a database, so when you're building your product, you can have a little sticker that has the MAC address and have it automatically print out, all that kind of stuff. You can integrate this into your production line and make Raspberry Pi compute module-based products much quicker. If you someday are in a factory and exploring it, you might find a thing like this and know that there's probably a Compute Module 5 inside there somewhere. So another source for grabbing a Compute Module 5 in the wild someday. But yeah, this is the CM5 Programming Jig, and this was sent to me by Raspberry Pi for my testing, and I will try to get this going for another cluster project so that I can use it and see, how the whole software stack setup works, because I'd love to be able to get 8 of these out, like pop 8 through very quickly so that I can iterate more quickly. That's one of the most annoying things about using this setup, is unplugging it, plugging it back in, putting the Pi on, taking it off, and the reliability problems I've had with the Compute Module 5 on here. Seeing the open pinout for this and seeing that there's software for this, I wonder if somebody could make an open version of something like this with just a little bed of nails, where you could have a little clamp on a board like this and get the same kind of thing done, but without having to have a very expensive jig like this. Very expensive being a relative term, because this is $600, and in manufacturing that's not a huge cost. But it's not something that I think most of the people watching this video will ever be purchasing for themselves. Yeah, there you go, Level 2 Jeff. I will see you soon.